Are you ready to see something amazing? This is the graph of y equals e to the x. And there's a tangent. I'm going to draw the tangent and have it go along e to the x here.
Derivative's the same. Not sure why, but it is.
Except right in there it's having issues. It's exactly the same. Which is a crazy thing. Because wherever you draw the tangent, the slope is the same as the value of e. And so we've got a new rule to remember. It's easy, but because it's easy, it's going to mess with you. It messes with you, especially with the chain rule, because you will want to do something when you don't do something. Okay? So we have our derivative of y equals e to the x is e to the x, which is really cool. Natural log of x. We're going to do that too. We're going to get there. We'll start with e to the x. Okay? So this is where I think it'll mess with you a little bit. You want to find the derivative of 5e to the x. It's going to be. And you're going to feel like you did something bad. Right? Because up till now, usually you found out that if you write down the question that they asked you, you don't get any marks. But in this case, you might. Because the derivative hasn't changed. Huh. Let's work backward. Yeah, you could find the 100th derivative of it. Work backwards. Well, when working backwards, what possibly could this have been before? It didn't change, but this would have been 3x to the 5. Maybe plus 15. Okay? Or add anything you want. But 15 is the number of choice. I don't know why we chose 15. So find the equation of the tangent of y equals e to the x at the point 0, 1. And we're going to draw this to show a picture of what's happening. Well, in order to find an equation of a line, you need two things. You need a point, which we already know. We know the point is 0, 1. We also need the slope. In order to figure out the slope, we find the derivative, because the derivative is the equation of all possible slopes. And when the x value is 0, y prime will be e to the 0, so our slope will equal 1. And now we can just go y equals mx plus b. We know that our slope is 1. We know that our y-intercept is 1, so we can just plug it in, and we get y equals x plus 1. If we show a graph of what's happening, do you remember how to graph e to the x? Kind of. So your graph of e to the x will have 0, 1, 1, e. And it has an asymptote. 1.73 is the square root of 3. That's where that number comes from. E is approximately 2 2.718281828, and it looks like this pattern keeps on going, but it doesn't. Question mark, question mark, question mark, question mark. It doesn't continue with that pattern. It's not a repeating decimal. Now, if I draw a tangent, the equation of this tangent is x plus 1. So far, so good. Now, what about other powers? If y is equal to b to the x, then the derivative stays the same, but you have to multiply it by the natural log of b. Should we see if we can figure out why this happens? Okay. All right, so let's see here. What could I do? Well, I'll fiddle around with it. So if we fiddle around with this equation a little bit, natural log of y would equal natural log of b to the x, right? And, okay, bring the x out in front, and natural log of y is equal to x natural log of b. There's our log laws. Okay. And now, just for fun, I'm going to say that if these two are equal, then would you agree that these are equal? Yeah? Using my power rules, oh, no, that doesn't quite work. If I'm multiplying, it would be like, well, I'll just keep it like, I'll keep it like this. I'll keep it like this because I like it like this. But on the left side, what is e to the natural log of y? It's just y. So all I did was rewrite y equals b to the x as y equals e to the x natural log of b. It's a way of changing my base a little bit. I wrote b to the x as a base of e. And now, if I would take the derivative of this, what's my outside function if we come in for a little, like, nice little math hug here? It's a chain rule. My outside function is e to the x. So what's the derivative of e to the x? The same thing. Nothing changes. But it's a chain rule. What's the derivative of the inside? Natural log of b. And this means this whole thing was originally equal to b to the x. So that proves where that formula comes from. Yeah. Yeah, because natural log of b, we're saying that when figuring out this, wow, this is fancy. There we go. I don't know. We're saying with this that b is any number. This is like figuring out 2 to the x, 3 to the x, 5 to the x, where b is any value that you can do a power of. Then this is what the derivative would be. So when we're looking down here, this is like natural log of b is some number, some constant. So if you had like 7x here, well, the derivative of 7x would be just 7. So whatever this number is, the derivative of this number times x would just be that number when you do your chain rule. But you're going to remember that whenever you have a base other than e, your derivative, so dy dx, what's the derivative of 3x? Well, it's going to stay the same, but you're going to multiply by the natural log of 3 plus the derivative of 5x squared would be 10x. We're going to check this one out. Here's our natural log. And if we did the derivative of any natural log, it is half of a 1 over x graph. And the reason why it's only half of the 1 over x graph is because the domain of natural log is just from 0 to infinity. You can't take the natural log of 0. You can't take the natural log of any negative number. So then when you do your derivative is 1 over x, but it only exists for when it's positive because that's when your original function existed. And the natural log is going to cause you some problems. It's going to cause you problems just because it looks so different from what you started with. Someone was thinking, as I said, the natural log is going to cause you problems. Someone was saying it's already caused me problems. It's not going to cause me problems. Since you introduced it in grade 12, it's been a problem. So derivative here, well, the derivative, if I do this in like 2 steps, the derivative of natural log is just 1 over x. So this, you could have directly gone to this if you can see that, but it just becomes 5 over x. So far so good, no chain rule, no quotient rule. Same thing if we wanted to find the derivative of logs of any base. And you can fiddle with this the same way that we fiddled with e to the x. You could use your change of base theorem to change this to a natural log. I'll show you that just for fun. So if you wanted to take the derivative of log of any base, so if I had y equals log base 15, just to make sure we use that number, x, the derivative would be 1 over x natural log of 15. And the reason for that is, not sure if you remember or not, but one of the things you learned in logarithms was the change of base theorem. And the change of base theorem, if I use the same letters that, that are up there, I have log a of m is equal to log b of m over log b of a. That was your change of base theorem. What that means for this equation is that if I start with log 15 of x, just like I did right here, I can rewrite log 15 of x as y equals, change the base to e, natural log of x over natural log of 15. Which is the same thing as 1 over the natural log of 15, which is some number, don't try to mental math it, times natural log of x. And what's the derivative of the natural log of x? It's over 1 over x. This is just a number in front. And we get this same result. So changing the base, again, figuring it out, is just based on these two ideas. That the derivative of the natural log is 1 over x. The derivative of e to the x is e to the x. And from that, we can now do any log base or any base of an exponential function. So here's one that's straightforward. The 2 would stay. The derivative of any log is going to be 1 over x, but this one, because it's a log base 7, you would have a natural log of 7 on the bottom. All right. Ready to stretch your brains a little bit and do some with all of the other rules? Together, or do you want to try it first on your own? Together? Okay. So first of all, whenever I see square roots, I would take the time to rewrite it as an x to the half. What's our main rule that we're going to have to? Product rule. Can you see that we have, if I split it here, one function with x on the left, one function with x's on the right. So, finding our derivative. Product rule says keep one of them the same. I'll keep this one the same, and I'll do the derivative of the other one so that I change it to e to the x. Right? It's good? Plus, now I'm going to keep the e to the x the same, as opposed to last time where I changed it to e to the x. And multiply by the derivative of the first one. So the half would come out in front. Subtract 1 from the exponent. And then we have our derivative. Yeah, and you could factor out, I guess in this one they wouldn't have x to the negative half in your answer key. They'd probably have this whole equation over a square root of x. So you would have to do that algebraic manipulation. When you're working on your homework, the answer, whatever you get after step 1, do the algebra to make it match the back of your answer book. Again, that's where your algebra skills will get really, really good. In fact, most of math does that. You learn something new in math, and it's hard, but while working on it, you really strengthen all the skills you had up till there. And you don't even realize that you're way better at all the stuff you did in grade 11 and grade 12, such as addition. You've got your 1 plus 1. I got that down pat now. Been working hard at it. Yeah. You want to try this one, or do you want to do it together?
I want to try this one myself.
Okay. I'll put up the answer in a bit. And the results are. Yeah, I simplified it a little bit, but this is the answer. The first line, that's the one you want to check if you got. Kept one the same derivative of the other one. Kept the other the same derivative of the first. It just is such a nice one to simplify because the over x cancels out within x. And you can factor out a 3x. You could make this into a product rule, or you could do it in the quotient rule. I'd suggest doing it in the quotient rule because that's how I think I've got my pre-made answer for you to match up. So you can be a better way of checking to see how you did. Quotient rule, keep the bottom the same, derivative of the top. Then keep the top the same. I'm going to subtract, keep the top the same, derivative of the bottom over the bottom all squared.
That's just what I'm telling you. I like to tell kids things. So he confirms it. That's what he confirms. It's like I know this is.
So for this one, I've got the solution up there just after one step, but this would be another one that in your textbook, because after doing step one, you're going to have a fraction inside of a fraction, because the derivative of the natural log is 1 over x. You would have to spend some time to simplify it. Yes, it would be negative 1 over x. But an unsimplified version would just look like that. But this one does simplify really nicely. And then you can factor out an x to the 4, and that all cancels out on the bottom. Very nice. No, I mean you can. If you wanted to simplify this, what would the textbook say? dy dx. It would all be over an x to the 6 in the end. You would have negative 11 plus 5 natural log of x. That's what the textbook would have as the answer. Just. That's right. So I have flashcards. I go home, I look at this, and I say, this is this. Well, this will, when you factor out the x to the 4 here, you'll get a negative 1 here. And then you have this 5 times that 2 will be 10 times the negative will be negative 10. Negative 1 and the negative 10 should make negative 11. You ready for the next one? Did you take the time first to change it to that? And now this is a chain rule with e to the x. So first you do the derivative of the outside function, which is the e. Nothing changes. And then you do the derivative of the inside function. Now, with an e to the x, it's harder to see the inside function because the inside function is actually in the exponent. It doesn't really feel like it's inside. So that can cause some troubles. Could simplify that too. The half and the 4 would go away. Put the square root of x on the bottom. Fun. Here goes. Keep one the same, derivative of the second one. The second one, it's going to be 1 over, keep the inside function the same.
I rolled 3 instead of 5.
And then multiply.
That's literally what I meant.
What happened? Okay. Now, I like this question. Something very cool happens here. What happens when you do 1 over 5x times 5? You get 1 over x. It, yeah. Yeah, it's this chain rule, right? So when we do the natural log of 5x, we have a 5x inside of the natural log. The outside function's natural log. Natural log says 1 over whatever's inside. So we have 1 over 5x. And then what's the derivative of 5x? You have to multiply by 5. Now those 5s cancel out and get 1 over x. So why is it that the derivative of natural log of 5x is 1 over x? Why is that no different than the derivative of natural log of x, which... Why did it become the same? Can you explain to me why that is exactly the same? E. It's like, well, that's the general answer for everything now.
They multiply and can't do like
e to the y equals 5x, and then e to the y equals x, e to whatever. Will you explain to us, Mr. Sure, you could. Yeah, I'm sure you can do it better.
Better? Are you okay with this? What did I do? I did that one. I did that. If you add 2 logs, it's the same as multiplying inside. Here we're multiplying inside. Well, what is natural log of 5? It's just a number. And what's the derivative of just a number? 0. So that's why it ends up being 1 over x. Isn't that crazy? Okay.
See, I know when it's there. Just do a gap. It's fine. So that's not happening.
And how did you do? Right? Natural log is the first one. It's 1 over whatever's inside. And then you have a chain rule, so the derivative of the inside is just 6. Yeah. You can also use the analogy of choking the function.
These pop up on the test.
Can you put one of those on the test just so I can watch him get up and actually going on?
What, huh? What? You did it wrong? Because I sure did. That's a chain rule. Good job. It is. I'm telling you it's a chain rule. Not people do it. This part is the chain rule. Would you put it before E? Why not?
Because what happens is the x to the 4 is function inside of that.
Yes. So this is chain rule there, but this is a chain rule. You would factor out a 7 e to the x4. This is how your textbook would write the answer for this one. They would factor out a 7 e to x to the 4, leaving you with 4x to the 4 plus 1. This is a chain rule. This stays the same. That's your first time you do the derivative. Then you do the derivative of the inside. And that's why the chain rule with e to the x is so hard, because step 1 is keeping everything the same. And the last thing you want to do when doing a question is not do anything. So it really goes against your feeling. I'll put up the answer for the last one here so you can check it. I would change it to that. I have a staff meeting.